Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a number of topics to cover, including some WAF bypasses, a universal cross-site scripting in Netlify's Next.js, and bypassing Chrome Sanitizer API. I guess we'll jump into our first topic, which is three vulnerabilities that were discovered in Netlify's Next.js lib, which was posted by Sam Curry. Next.js is used across many cryptocurrency websites and such due to its Web3 support. And the post starts off by detailing some of the different problems and attack scenarios you have within the Web3 ecosystem, especially when it comes to the big three: CIA, confidentiality, integrity, and availability. Particularly when it comes to integrity, because when you're dealing with these crypto-based sites, whether it's to buy NFTs or send a transaction or whatever, you have to be able to trust the data you're getting is legitimate. Most people aren't going to be, digging into the blockchain to verify addresses or something, especially if it's a trusted site they've used before. So, yeah, we've covered some attacks and scenarios like this before on the podcast. I went back to try to remember which episode it was. I don't know if you would have that, Z, but there was one episode where we talked about a website where the idea was using a cross-site scripting to um, put up a fake transaction for like an NFT or whatever, and it was used, or it could be used to steal money in that respect. But I couldn't remember which episode it was.
Yeah, I do remember the issue you're talking about. I don't remember which episode it was.
Yeah. Also, just from chat, are you guys linking this? Yeah. Sorry, I will put links in chat as we go. The bot is still on vacation a little bit, the link bot, so we'll get that working again soon. But right now, it's not working. All right. But yeah, so obviously integrity is a big problem when it comes to Web3. You have to make sure that the data that's being sent to the client can be trusted, and the client has to be able to trust that data. So with that in mind, they went and audited Next.js and ended up finding three issues. The first of which was a relatively straightforward one, and it was an open redirect in the next image endpoint for loading resources. Um, and this would take a URL parameter from the user, and it would use it to send a mock HTTP request to itself. The problem seems to be that you can pass slashes into the URL parameter unencoded and redirect to an arbitrary site, which they say isn't normally possible to pass. Like, they say backslashes unencoded in regular HTTP requests. It's a little confusing what they mean here. I'm assuming the main point is just the fact that you can pass slashes in that are unencoded, but the way it's worded is a little bit confusing there, so I might be missing something,
Yeah,
possibly.
this
But
this part confused me a little bit also. I mean, what they do is they're sending in this backslash thing, um, which then seems to result in the actual location being a slash followed by, or no, sorry, not preceded. They've got a slight change though, because they send in these four characters before it and get out kind of this extra slash before the example, which seems odd to have that. And either
yeah,
following, I mean, I don't know. This one, yeah, you're saying escaping the out of chat regex generator, escaping the slash, so it looks like slash example. And I mean, the thing is, they started off with the forward slash unescaped, and then they escaped the second forward slash, and then they include another backslash to escape the E. It doesn't exactly make sense what's going on here, but I'm going to put it this way. It seems that this magic invocation gives them an open redirect.
yeah.
I could see, like, the slash doing a double slash URL, that kind of makes sense. Exactly what's going on here, I'm not sure. I'd probably have to dig into the commit, see the fix or whatever on this, and see kind of what's going on. Because it does seem to have to do with trying to access a folder that doesn't exist. So there is a little bit going on here. These trees ask why the backslash before example. That's the same question I have, honestly. They seem to have gotten this with this invocation of slashes, but I'm a little bit unclear on exactly why that works. I
Yeah.
usually try and dig into it, and I did actually spend a little while trying to dig into this one. Unfortunately, I wasn't able to make a ton of progress on that.
Yeah, it could potentially be a typo maybe on the second one with a location, but I wouldn't want to go to that right away just because the entire idea of like doing this the stuff with the backslashes is the root of the issue. So like messing that up in the write up would be uh would really suck for the reader. So I'm guessing it's just something we're not understanding with like the back end. They're doing some kind of weird thing when it comes to backslashes um that is causing it to transform into this situation where it tries to access a folder. Um, and this part's a little bit weird too, because it would try to the default behavior of Next.js servers is to redirect users when they try to access a folder that isn't accessible. So that's kind of like what they're trying to convey here is the fact that you're able to fake a folder, the folder doesn't exist, so that's what causes the redirect, and that's where the open redirect comes from. But yeah, how exactly it gets there is a little bit unclear. Um, Something interesting that gets called out also is the fact that the redirect would happen on the user side versus the server side, which seemed a little bit strange. Though that's because an error was being triggered on the back end where the URL ended in a slash, so it would break out, and it didn't follow it server side. So yeah, there was a lot of interesting stuff going on with this first issue, basically. But that behavior also led them into looking at what was the second issue, which is a cross-site scripting and SSRF in the Netlify IPX library, which is installed by default on a lot of Netlify applications. IPX would set up this route that was similar to the previous next image route, where it would take a path to load a resource, and it too would allow external resource loading rather on Netlify's IPX library, but only on whitelisted hosts. The problem is, it seems that the parsing that UNJS UFO was doing, which is what Netlify relies on, was bugged in a similar way to the first issue. You could just add a whitelisted host, depicted as example.com in this case, and then use an encoded backslash and the attacker URL. And in that case, you could just pass a malicious external SVG, which, if it had the image SVG XML content type, could be used for XSS. So this one was a little bit more clear and straightforward how it worked. It still relies on the backslash, which we don't know fully what's happening on the back end here, but um, yeah, it's kind of a similar issue to the first one. Uh, it's almost like a variant, if you will, in a slightly different area. The final issue was the universal cross-site scripting that the title mentions and was also in the IPX route. As they discovered, the IPX code would read the hex-forwarded proto header to allow other protocols to get used. And if you did specify another protocol, um, it would just take that and substitute it into the string for building up the request URL. So because of that, an attacker can just specify an X-forwarded proto header to whatever domain they control and get control over the URL the request gets sent to. So really straightforward exploitation there. And it's also universal because you're not relying on having to put a whitelisted domain at the front end of the payload. So yeah, pretty cool final issue to close it off. And yeah, a few different vulnerabilities in Netlify there. Nothing super complex, mostly just bad parsing code. Although I would like to understand the first issue a little bit better. Maybe we can dig into that a little bit more after the fact. But yeah, I mean, super bad parsing code from what I can deduce from these vulnerabilities, but the impact here is fairly high because Sam Curry states multiple times in the article that this Netlify lib has pretty widespread adoption in Web3. And Web3 has a huge financial motivation for attackers to abuse these types of issues. So, um, yeah, pretty high impact issues as they go.
Yeah, I appreciate them opening up, talking kind of about how the Web3 websites do differ from your standard web app. Because I mean, there are a lot of similarities in the sense that you've still got a web app and still kind of vulnerable to those things. But the threat model does change when you're dealing with largely, static websites, denial of service and availability isn't quite like the same criticality, I guess, with these sort of app stuff. I did appreciate kind of that starter bit. And also, earlier you brought up a prior vulnerability which we covered. I did go and find that was on Rareable's NFT marketplace, where there's the wormable cross-site scripting which we covered in May of last year. or not last year, last season, May of this year still.
Right, yeah. I remember it being like a fairly recent episode, which is why it was frustrating me that I couldn't find it. But yeah, it was nice that you found it there. So yeah, that was episode 141. Um, for anybody that might want to refer back to that, that was actually a pretty cool issue. So it would be worth checking out if you missed it. All right. With that out of the way, though, we'll get into a post by Asset Note on a pre-auth RCE in BitBucket, which was inspired by William Bowling's GitHub Enterprise RCE finding from back in 2020. Toward the top of the post, they go through setting up their testing environment with running a BitBucket server from Docker Hub and using PSPy for doing some log parsing. But then they get into a vulnerability they found in the methodology section, which was an argument injection in a Git subcommand. So for those watching, you may be able to see here they have this path um, where there's a REST endpoint, and this project user's repo1 browser endpoint had an at parameter, and they tried injecting help, the help argument, into the Git command, and that ended up working. But that didn't have any security impact because help isn't really going to get you anything useful. It didn't seem like there were any other useful arguments they could inject. But it was a promising sign. If they found one, then they could potentially find others in that same area, which they did. Um, in the next paragraph, they detail another endpoint they found, which was vulnerable to argument injection, which was in the latest project's repo archive endpoint for streaming an archive of repo contents to a given at a given commit. And when they looked at the documentation, they found that the endpoint would take a prefix parameter, which would map directly to the double dash prefix argument to the archive subcommand. With some knowledge of command and argument injection and how they worked, they tried one of the more common tricks and built a test payload with padding, followed by a null byte, followed by this option argument, which is an invalid argument. It's just something they were testing with. And then another null byte and padding, which when they tried that, they got the error saying that option wasn't a valid argument, confirming that that archive endpoint was vulnerable to argument injection. The reason this happened, which they don't really go into until further down in the post where they root cause, is because their process builder would use the native Java function fork and exec to launch the subcommand. And that function just takes a character array for the command argument, right? And indexes inside of character arrays are separated by null bytes. So by being able to pass in a null byte, they could basically smuggle their own indexes inside of that character array.
And somewhat importantly here is it depends on that translation between the Java strings, which just use the prepended size byte, or I think it might be a couple bytes, but it has the size kind of ahead of the string, so there are no special characters. Whereas, of course, when you go into Java native stuff, that's generally in C, which is going to be using the null terminated string. So when it converts the Java string array into the C array for using with this native function, you just kind of get this extra element introduced.
Yeah. So exploitation is always a little bit interesting where argument injection is concerned, as what you can do with it is very context specific. In this case, they lucked out a little bit and found that get archive had an exec argument, which would take a path to the get upload archive binary to execute it. And the way that they exploited this issue was they just basically passed that path into, um, well, okay, rather, let me step back a minute. The get archive exec argument, the way that would work was it would just pass that path into exec VE of bin sh. So exploiting was pretty straightforward because whatever path they passed in there would just go through to the shell. They weren't doing any like kind of validation on the binary that was getting provided for get upload archive. So yeah, very straightforward exploitation primitive. By simply passing a prefix that smuggles in exec, they get command execution. Now, as I said at the beginning, this is a pre-auth accessible vuln. There is some stipulations though. Because of the way that the path works with needing the project key and repository slugs, you would need those if you were going to try to hit this endpoint. So there are some conditions to exploit it. You do need some information, but it's still a pre-auth RCE, so impact is still pretty high there. It's just got a few requirements. Overall, pretty interesting vulnerability, like Z was talking about. With these are the types of issues you could end up getting when you have to convert from like the higher level language strings into lower level and null termination. It's a very easy issue to have pop up, so I'm not too surprised that it turned out to be an issue in this case. But yeah, pretty good post by Asset Node and a cool vulnerability.
And their methodology section is also worth calling out. Just the way they went about it basically is getting logging on all of the commands that get executed by the local environments they can track for all of the syncs to get. They do talk about the tooling that they used for that, PSPy, which I'm unfamiliar with, but it is something that you would be able to apply to another program, either something else using Git, trying to follow for that, or anything else. And yeah, I mean, it seems like a bit of an easier way. I remember I've looked in the past for code execution in a similar way, and I was more looking at the code itself, whereas this is a bit more of a dynamic testing or a dynamic analysis way of going about it. It's worth calling it out. It's an option for it. And IA2BR mentions PSPy is great and highly recommend, so we've got a recommendation for it.
Oh, there we go. All right, so Chrome also had an issue disclosed in the last few weeks that was reported in March, and I'll let Z get into this one, because this one, it's a bit of a multi-layered issue, and we had to dig into the comments a little bit to see what was going on in terms of another bug being discovered.
Yes, this one is a bounty, so they got $1,000 bounty for this one. And should also mention, actually, I believe it was the last topic where they got a $6,000 bounty.
Yeah, that sounds right.
Yeah. Yes, that one was a $6,000 bounty. We didn't mention that. So this one got a $1,000 bounty, but the issue is closed as not a bug. I don't think I've seen that before, where they still got paid out. And it's because even though this one was closed as not really being an issue, they did uncover some that was an issue related to the report. So the first thing, and kind of the core issue here, is just the idea, I wanted to shout out, of bypassing the Sanitizer API using prototype pollution, which I don't think has been discussed at all. I don't recall really seeing this. Kind of makes sense as a target if you've got it. You do depend on them actually passing in the object versus if they just use empty brackets, then the prototype pollution won't end up working. But if they do pass in the polluted object, then you can perhaps get some rules set up that will enable either XSS or something a little bit more useful than what the sanitizer should allow. So it's an interesting way of attacking the Sanitizer API. I just wanted to shout out the actual issue that they found as a result of this is the example that they use here shouldn't work regardless of prototype pollution or not. Also using prototype pollution to attack the Sanitizer API, they decide that's just JavaScript being JavaScript, and they really shouldn't be introducing extra complexity to protect this one API against the particular vulnerability, and just leave it as that's what the JavaScript language supports, and therefore, it's okay. So now the actual issue that got paid out on is also a little bit interesting, just in the fact that it existed in this particularly security sensitive area, and that is this allow elements with the SVG. So they're basically saying, allow whatever elements, giving the allow list for them, SVG, SVG, and SVGUs. The bug was basically that they would misclassify any. So in kind of HTML, you've got the different namespaces. You've got your normal namespace, or your regular space, which is like your A tag divs, all your normal things. It can also classify things as custom. So if you're actually registering a custom element. And lastly, you've got namespace things like SVG, where under SVG, you can have some special tags you can use. Or math is another one. Yeah, special tags under there. The issue was when it tried to classify these, normally SVG would be classified as just kind of under their regular setup, and then it would hit their normal HTML baseline lookup and be like, okay, this is this sort of element and drop it because it's just part of the baseline and not something they're going to let through. You shouldn't even be able to allow elements and let this through with the Sanitizer API. And the issue is basically anything under the namespaces SVG or math, or I'm not sure if there are other namespaces. Those are the two I really see mentioned a lot. Anything under namespaces just got categorized as unknown and was able to slip through and go through a few other checks and potentially be enabled, as they did here. It was just straightforward not matching on any of the namespace elements.
Yeah, and just to clarify for those who might be listening and can't see the proof of concept code, basically what they were doing at the prototype pollution is because you can pass a config object to the sanitizer to have like a whitelist of elements, they were using the prototype pollution to set allow elements themselves, and we're adding SVG into that list. But the bug that Z is talking about is the fact that it could even get that far. Usually, if this was working correctly, you shouldn't be able to pass SVG elements even if they were in the allow elements array, because they're just not supposed to be allowed regardless. So yeah, it's a little bit interesting with how they're able to uncover that deeper issue. And yeah, I don't think I've seen that before either, where like a report that was closed as informational or whatever would be rewarded a bounty. So that was kind of cool. But yeah, it's a really like interesting idea, just using prototype pollution against the browser's own security APIs. I mean, it totally makes sense to try it in that way, but yeah, like IDBR said, it's kind of like a galaxy brain idea. Like, let's use it against itself, basically.
Yeah, and that was one of the key things I wanted to call out is, it just seems like a really cool idea and something to keep in mind if you're up against Sanitizer API. I mean, you would need, depending on how Sanitizer API is getting used, you might need this pretty early on if they create the sanitizer early in the process, as I would imagine they do. But you could also imagine a sanitizer being created like as needed, and you'd have more chance for a pollution to actually impact it. But yeah, it is, like I mentioned, also kind of fun, just, not fixed, but still given the bounty. I did also open up briefly the actual spec for it that kind of explains how the sanitizer config is supposed to work. Where for these baseline elements, it's supposed to just drop them and not even get far enough to check the configs. So you can take a look at the spec if you really want to dig into it. It has been fixed now, but it was present and was there.
All right, so we'll get into our next post, which is from Cider Security, rather. got tongue twisted there, and it talks about some techniques using webhooks of source control management, or SCMs, like GitHub and GitLab, to get access to internal CIs, such as Jenkins instances. I'll let Z take this one away as well.
Yeah, they really do just focus on the Jenkins instances in this post in terms of what they actually do with it. But the principle applies elsewhere, and you could probably use this for finding other issues. But core idea is really just, in a lot of cases, a company is going to have, a Jenkins setup or some sort of CI service. Jenkins being one of the most popular of those services. And they're going to want that to interact with their source code management system, like GitHub or GitLab, to have those webhooks on like a push to main or something. Hit their CI service, kick off a pipeline to build or whatever, but they probably don't want just the internet at large to be able to access their Jenkins instance. That's less than ideal. So what some companies will do, and not what's necessarily recommended, but what they can do is just whitelist the source code management IPs, all the webhook IPs they'll be using, whitelist them to access Jenkins. And this is kind of talking about abusing that sort of access where you have a webhook, because on GitHub, you can set up a webhook to anywhere. It doesn't have to be your Jenkins instance that you're pointing it to or your CI. You can put it wherever you want, including some corporate CI, and try and abuse that access. So what they were looking at is different endpoints they can try and hit, and a couple core things they did figure out early on is how each of the services, GitHub and GitLab are the two that they looked at, how those services treat redirects. Key thing being that GitHub would not follow any redirects. It would you'd be able to see the response back saying like this would have redirected, but and showing you like the location here, but wouldn't follow them. GitLab, on the other hand, would follow redirects. And that becomes important when it comes to what type of endpoints you can actually reach with any of these webhooks. With GitHub, you're really just limited to endpoints that will accept a post, and you don't really have much control over the post body. That's going to be all the webhook information. With GitLab, you can take advantage of a secondary redirect, like an attacker website that will redirect elsewhere to drop the body and turn it into a get using like a 302. Side note: if you're ever in a case where you need a redirection to happen and you want to actually keep the body, more common if you're in like maybe an SSRF and you want to leak information from the body, you can use I think a 307 or 306 will do that. There are a bunch of redirect codes. Some of them will keep the body, some won't. A lot of people are just familiar with the more common redirect codes. Anyway, that is unrelated to this post. Coming on with this one, one of the first things they kind of targeted or actually pulled off was just an authentication brute force. Honestly, doesn't seem super practical to me, doing any sort of brute forcing over the internet. But they basically found, they could hit the Jenkins login page effectively, send their username and password, and the Jenkins would accept the parameters in the URL rather than the post body. So even though it's a post request, it'll still parse the URL and it'll treat any parameters that are in the URL as the equivalent to having come in the post body. So by setting up your webhook to point to the auth location, you can basically brute force password, brute force the login. Really, like, it feels to me like you're going to have a big time span, needing to do the commit, needing to do something that triggers the webhook every time. On a network thing, it just doesn't feel super likely. Garlic, Garlic 0x539 in chat also mentioned, is this just useful because it isn't rate limited? I believe you can set up rate limiting on Jenkins too. So that's another aspect of it.
It's mostly like what they're calling out is mostly just the fact that you can hit the login endpoint at all because it is internalized. It's not supposed to be exposed to the wide internet. So the fact that you can potentially brute force this login page is like a bit of an issue. Like you're saying, practically, I don't really know how that's going to happen unless the password is super weak, maybe, or they're using like default creds. Which, to be fair, maybe they would do because they're like, okay, it's an internal instance, nobody can hit this from the internet, who cares? But yeah, it does rely on the setup being kind of poor for this to even be like taken advantage of, I guess.
Yeah,
In a useful
Rudimal
way.
mentions like try top 100 passwords. Yeah, there are totally ways you can do this. I'm just saying, like, on a practical sense, you're not pulling off a big brute force attack with this. Just generally speaking, network brute force isn't a great thing. And yeah, there are some issues, but you can do it. And it does start off, kind of kick off the rest of the chains once you're logged in. Now, all of the webhooks are stateless, which would mean that you do have from this webhook and get perhaps to a endpoint that you actually care about. Or I mean, you could just be leaking the credentials this way too. But thank you, Imperial G, for the 9 months of Twitch Prime. So yeah, jumping back on what they kind of found here, the brute force, it's kind of the first issue that they had there. And then with GitLab, because GitLab would follow those redirects, beyond this, they also found that they could actually start exposing sensitive pages. In particular, there's this from parameter used in the login that they could use to internally redirect themselves after the login. So they talked about using that to end up heading the console text.
So it's worth noting that is something in GitLab. So the article kind of diverges here, where it talks about GitHub first and kind of the limitations with GitHub. You can't really do as much cool stuff with it. Basically, you don't have as much control. It won't follow the redirects, obviously, and it doesn't display page contents. GitLab supports the redirects with that from parameter, and it also displays the page contents as well. So that lets you exfil some useful data or whatever. There is a bit of a difference though between like what you can pull off with GitHub and GitLab. GitLab lets you do a lot more cool stuff, basically.
Yeah, as I mentioned, this is at this point just hitting the GitLab webhooks or another system. I mean, this idea is at least something you could apply to any time you have um, compromise on any sort of, I mean, it doesn't even have to only be a source code management system. Could be something else, but you can imagine this sort of particular setup where the SCM is allowed to access something like Jenkins and does have that privilege level of access. While it's not the best route to go for allowing a remote source system to access your CI system, it is an easy way of doing it where you just whitelist everything. So it is something you can definitely take advantage of. So I thought just the exploration of the concept was kind of worth looking at here. So yeah, the next one they kind of go for is full chaining RCE. This does rely on Jenkins running an old version, a 2019 vulnerability that Orange Sai reported. That's documented in his own blog. It takes just a single GET request. Using that, they're able to get an RCE using the webhook. So it's an option. I won't dive too much into that because it is just a known vulnerability. It requires it already be running the vulnerable version and just not accessible over the internet. But if it's accessible through the webhooks, GitLab could at least compromise it. On a whole, though, the idea of these sort of privileged servers and being able to set up those webhooks to attack those internal services, I think is a neat idea. Something worth exploring maybe a little bit deeper with some other services, but this particular setup is kind of a major one that comes to mind, where it's also likely other users may have access to spin up those webhooks. I mean, anybody can use GitHub or GitLab. Obviously, if you compromise like a private instance, that could also be a way of escalating.
Yeah, and for the brute forcing part of it, Rudimal mentions, I guess, doing some OSINT and looking for people who work for the company and might have leaked passwords. Yeah, I mean, there are some ways you might be able to take advantage of this and make the brute force more practical. Um, it's just something where it's going to be fairly slow, and it could even be audited. Like if somebody's looking through their logs and they see, oh, there's a bunch of login requests with like from the from the SCM, and it just keeps going and going. It looks pretty obvious if they're doing any amount of auditing, which is actually something that cybersecurity mentions in their resolution section as like a tip, is to have auditing like that set up. They also have some other tips like just restricting the access to endpoints from a CI from the SCM so that they can't hit something like the login endpoint easily.
That's
Also
honestly the big
disabling
thing.
an anonymous access. But yeah, that's the big one, is just restricting access to endpoints so that these kinds of attacks aren't possible at all.
Yeah, like my ideal
So
setup would be you have your server that receives basically a token from the SCM and then proxies the request along, or does like a reverse proxy sort of setup, something that can just authenticate a random token used just for one repository, map that onto the webhook it's allowed to actually hit and proxy the request that way. Takes a little bit more effort, has a little bit more of a performance overhead, but that way you're not opening yourself up to, well, hitting anywhere. And I mean, Jenkins doesn't have to be the only service. Jenkins is the one that they looked at here. It's not the only CI system. There
it is
are
probably
other
the most
options.
popular
So
though.
it is, yeah, one of the most popular, or the most popular, I believe.
Yeah. So they were just kind of looking at a setup that involves the most popular software you'd see, but yeah, like we've kind of hammered almost multiple times, this idea, this concept, can be applied to other setups, and that's one of the points they try to make in the blog post. So we're shouting out, is something to keep an eye out for. Is like abusing webhooks in this way. I don't think we've talked about it too much before on the podcast, but webhooks can introduce some interesting attack vectors in general. So Yeah, it's always something to look at if you find it in a setup of a target you're looking at. All right, so our last topic here is a few interesting web application firewall bypasses that a security researcher by the handle of Tirshank found in ModSecurity. There's 3 techniques or chains that are documented here. First of which was a content type confusion between the WAF and the backend due to 2 rules in the ModSecurity's recommended config. Um, and yeah, it uses regular expression parsing, so we're back to bad regex, basically. Starting with the XML request body parser, they found the content type rule would try to match for XML content types, but the problem is it doesn't match to the beginning of the string. So by simply having a different content type that has application XML somewhere in the string, it'll get matched and interpreted as XML on the WAF side of things. And since ModSecurity ignores comments, you can use comments inside of the XML to bypass the WAF as well. So that's kind of the first technique that's detailed there. They had a similar bypass with the JSON request body parser, but that one was a little bit harder to exploit because I guess just since JSON is a bit more strongly parsed, it was harder to get a payload in that could hide as valid JSON. They did eventually manage to find one though using quotations, so they detail that one. But I think the XML one is probably a little bit more useful as a WAF bypass in general. The second technique talks about using multi-part form data, which basically consists of requests noted by a boundary prefix with a double dash and a content disposition header. So they ask the question, well, what if you just don't provide a body for the request? And it turns out you can get some different behavior. ModSecurity, for example, would just take the empty body as there's nothing here,
Just
continue
to
on to the
jump in,
next part.
sorry. It's an empty body for the parameter, not the entire request.
For the parameter, yeah. Good shout. So yeah, if you didn't provide a body for the parameter, it would just say, okay, there's nothing here. Let's just continue parsing the next parameter. The problem is some backends would start reading the next part as if it were part of the body of the first part. So you have this desync between the backend and the web application firewall. Another issue when it comes to multi-part form data is the fact that single new lines, as in like just a single \n or line feed, would be treated as a CRLF after the body. So if you used a body with a single new line terminator, ModSecurity would then start parsing the next part as a separate parameter, but most backends would still treat it as part of the body and only treat it as one parameter. So just some disagreement between ModSecurity and the backend, which could lead to bypassing the web app firewall through the desync, basically.
Yeah, and I will mention that when it comes to the empty body of the parameters, the author calls out specifically that ModSecurity does actually parse those correctly. But PHP apparently calls out this exposed PHP backend, or yeah, this example caused all PHP backends to be bypassable. So it sounds like that's something that PHP is interpreting it incorrectly, whereas ModSecurity understands the request correctly. Or did I? Yeah, however, some backends will disagree with ModSecurity. So it does sound like it's PHP in particular that has this issue, possibly other things, but PHP is one that the author calls out.
Yeah,
it's
it's
hittable
one of
because
those-
ModSecurity doesn't interpret it the same way.
It's one of those situations where it's not totally clear who is at fault because it's ultimately a disagreement between different pieces of software.
It's PHP or whoever the backend that doesn't agree with ModSecurity that's at fault. That new line should not be interpreted as RN. It just shouldn't be. You're expected to have \r/n as that delimiter. And by just going for the /n, that's just wrong by spec. I would squarely put the blame on anybody parsing it and continuing on. It just sounds like they have the example there of PHP doing it. They're not explicit, but calling out PHP there as they're bypassable makes it sound like PHP is kind of at fault there. But yeah, I would definitely put fault on the parser who treats N as RN.
Yeah. At least with the body being terminated by a new line, though, the article states that most backends will parse it as like one part, whereas ModSecurity will do too. So that's at least with that one, it seems ModSecurity deviates and might be at fault. But again, it comes down to a disagreement, which is also the final issue, which was character set confusion. This was basically down to a character encoding disagreement where if you could somehow get the
Sorry,
char set
I am
switched.
going to interrupt you. Just so
Yeah.
I can backtrack what I was just talking about. I was talking about it as the RN and the N being interpreted wrong. Yeah, that was mod security being wrong, but I was actually looking at on screen and in my head talking about the empty body thing, and the fall would be PHP with the
Okay.
empty body. Yeah, sorry about that. I kind of was looking at one thing and saying the other one. Go ahead with the care set confusion.
Yeah, no worries. So yeah, if you could somehow get the char set switched to UTF-7, which they were able to do by chaining with the first issue, CRS would try to block any encoding that wasn't UTF-8, but they'd only do it on the first char set parameter. So by just setting it twice in the content type, they could switch to UTF-7. UTF-7 is kind of interesting in the way that it lets you encode characters as base64, which then bypasses the firewall because I guess they were expecting like UTF-7 not to be able to get through, so they just don't deal with the base64 encoding. So yeah, some cool tricks spawning from some of the parsing issues we've seen before when it comes to parsing requests. Some easy mistakes to make, like just not matching the beginning with regex or treating a simple new line as a CRLF. And Rudimal says, if I was in charge of the specs, I'd just put only \n everywhere. Yeah, CRLF sucks. There's so many issues that have popped up from it, and it's bit me personally when I've been working on stuff a lot too. So I would definitely vibe with that statement. I hate CRLF, but it's here to stay. Unfortunately, it's been around forever. So
Yeah, has a
it's
lot of
something that we have
history
to deal
behind
with.
it.
Yep. And it's definitely been a strong point of argument before. I guarantee that. So, yeah, just basically comes down to disagreements between how things should be parsed, or some parsing issues like the regular expressions. Again, this post is something that you could probably take into, like, keep in mind for looking at other like web app firewalls as well. Similar bypasses might be possible because this stuff can get tricky, especially when the spec isn't like super clear to follow, or the implementation is just easy to get wrong. So yeah, definitely something that could be taken into other setups and probably exists elsewhere too. All right, so that's basically all of the solid topics that we have to cover for today. Z does have a couple of shoutouts, which I'll let him get into here, and then we'll wrap it up.
Yeah, two shoutouts for this episode. That is, one is cloning internal Google repositories for fun and info. This is a fun topic. I didn't really want to cover it as its own topic here, just because the core issue is he found an asset that was exposed on the internet. It had sensitive information, or could be used to get sensitive information. Talks a little bit about his process of, actually coming across it and some other little internal facts. So it's worth at least checking out, but I didn't find the vulnerability itself interesting enough to cover. Still worth a shout out. And the second one was a post from James Kettle. This time, not so much looking at he does look at a specific case study, but how to turn security research into profit. Has almost like a follow-up to the how to be a security researcher. Has a little bit of the same advice, but then going from research to how do you actually start trying to profit from it. Has some of the same advice in terms of like looking for overlooked research, identifying opportunities. Just a good post that I wanted to shout out. Yeah, those are the two shout outs I have for this week.
All right, yeah, and I will just say to add on there, like, pretty much anything from Portswigger is worth checking out to because they put out a lot of like good research that is portable. Like, yeah, they might have specific case studies, but it again, I've already kind of iterated on this, but it's one of those things where you spot it a lot in the wild if you're looking for it. James Kettle's posts kind of have that attribute attached to basically all of them. So whenever he puts out a post, it's worth checking out, generally speaking. All right, but yeah, that's all the topics we have for today. Thank you, everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. But yeah, with that said, we'll be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, which is where we'll also cover the Spot the Vuln solution that was shown in the pre-stream. We also have that in the Discord as well, for those who might have missed it. We now have a bit of a nicer Spot the Vuln channel set up with Discord's new forums feature. So, yeah, feel free to head into the thread for it and take a look. And yeah, with all that said, we'll see you tomorrow when we return for the Binary Podcast.